Hello class, this is Mr. Wood. Today we're going to be taking a look at definite integrals. So what are definite integrals? Well, a definite integral is an integral with upper and lower limits. So you can see right here we have our integral sign with our function, but we have this a and b here. So the a is the upper limit and the b is the lower limit. So these are expressed as the difference between the values of the integral at the specified upper and lower limits of the independent variable. So basically what that means is we are finding the integral and we are going to plug in our a for that whole integral function and subtracting the whole integral function evaluated at b. So definite integrals are a lot of the same of what we've been doing with the indefinite integrals. We're just taking it a small step further, so you can expect this to be a pretty short video. We'll have a couple examples. So here's the first one. We want to find the definite integral of the function 3x squared plus 4x minus 1, and we're looking at the upper bounds of 4 and the lower bounds of 2. So the first thing we want to do is find the integral of this function. So this one is a simple power function. So if we have 3x squared, well, we're going to add 1 to that power to make it x cubed, and then we want to divide by that power. So 3 over 3 is going to be 1, right? So we just are left with x cubed. For x, same thing. We have x to the first, so add 1 to that power and divide by that new power. So 1 plus 1 is 2, and 4 divided by 2 is 2. Alright, and then right here, minus 1, well, we have something without an x attached to it, so we can see that's the same thing as x to the 0th power, right? So 1 times x to the 0th power, add 1 to that power, and divide by that power, so 0 plus 1 is 1. Divide by 1 is, well, 1 divided by 1 is 1, or in this case, negative 1 divided by 1 is negative 1, right? And then we never want to forget our plus c. And so remember that this integral, or this antiderivative, is denoted as capital F of x if this function is our f of x. So what do we want to do now? Well, we want to just find what the antiderivative evaluated at a minus the antiderivative evaluated at b is. So what we're going to do is we're going to take that function, plug in a, and then subtract that function when we have plugged in b. So from here we have 4 cubed plus 2 times 4 squared minus 4 plus c, so that's when we plug in our upper bounds, and then we want to subtract the whole antiderivative evaluated at b. In this case, which is 2. So we have 2 cubed plus 2 times 2 squared minus 2 plus c. Okay, so from here we just want to simplify some stuff down. So let's start adding stuff together. We got 4 cubed, 64, plus 2 times 4 squared, well 4 squared is 16, minus 4 plus c, and then minus this whole thing, so 2 cubed is 8, plus 2 times 2 squared, well 2 squared is 4, minus 2 plus c. Alright, so we'll continue to simplify that. All this stuff on the left side is going to add up to 92, and feel free to add that up together yourself. Same thing with the right side, all of these things added together is going to be 14. So now we have 92 plus c minus 14 plus c, quantity 14 plus c. So we want to distribute this negative sign to both the 14 and the plus c. So we'll have 92 plus c minus 14 minus c. So you can see here that the c's cancel out. And actually I'm going to do that in red here. The c's should cancel out. Right? So now we're left with just 92 minus 14, which we should find is 78. Right? So with any definite integral problem, the c's should cancel out. And so that's another thing that contributes to it being a definite integral. We definitely know it's 78. But yes, like I said, these c's should always cancel out. If they don't cancel out, you know that you might have messed up somewhere. Alright, so let's go on to our next example. We're going to use some trig functions this time. So we are trying to find the definite integral of the function sine of x minus cosine of x, where our upper bound is pi and our lower bound is 0. So again, let's find the antiderivative of this function. If sine of x minus cosine of x is f of x, little f of x, then we know that capital F of x should be negative cosine of x minus sine of x plus c, right? Because if you take the integral of sine of x, it's going to turn into a cosine of x, but we also have to flip the sign. And then same with cosine of x. if we are taking the integral, it's going to turn into sine of x. However, in this case, we don't flip the sign, right? Because if we take the derivative of sine, positive sine, it'll be positive cosine, and the derivative of negative sine is negative cosine. Okay, so here's our antiderivative. Same thing with the last problem. We want to find the antiderivative evaluated at a minus the antiderivative evaluated at b. So here is that. We have negative cosine of pi minus sine of pi plus c, minus the quantity negative cosine of 0 minus sine of 0 plus c. So we just want to evaluate this antiderivative here, right? So negative cosine of pi is going to be negative times negative 1, right? Because cosine of pi is going to be negative 1, and we have that negative sign in front, minus sine of pi, which evaluates to 0, plus c, and then minus the quantity negative cosine of 0, so we know that cosine of 0 is 1, but we have the negative sign in front, so we have negative 1, minus sine of 0, again, sine of 0 is going to be 0, so minus 0, and then plus c. So let's simplify that down a little bit. These two negatives should cancel out, and we get a positive 1, minus 0 plus c, and then minus this quantity, well, negative 1 right here, minus 0 plus c. Continue to simplify that down. We're going to end up with 1 plus c, right? That 0 is just going to go away because whatever. This negative is going to distribute to each term here. So negative times negative 1 is positive 1. The 0 is just going to go away, right? And if we have a negative and a plus c, that's going to become a minus c. So again, these c's should cancel out. And we're left with 1 plus 1. Gee, I wonder what that is. We get 2, right? So, like I said, these problems are just pretty much what we've been doing, just one step further. So hopefully it shouldn't be too hard to grasp. However, these do require a little bit of practice, especially with the bookkeeping and figuring out the negative signs, adding things together correctly. And the hardest part is probably just finding the integral or the antiderivative itself. So just make sure that you have all of those things down pat, and you should be good to go. Make sure that you are familiar with this stuff for the next class period. We'll be working on it just a little bit more. I hope to see you in class, and have a great day.